Very warm welcome to everyone watching this video. My name is Yash Srivastav and I'm a co-founder of Tinsy Race Cars. Uh, uh, we are trying to make a video over here to give you some basic, to help you out with some basic CAD skills, which can enable you to make a human figure that you can use as a driver or as a co-driver in your competition car. So generally we are aiming to make this video for student teams who are preparing for events like Baja, Formula Student, FSA and Supra SA and events like that. So one of the biggest challenge in front of competition car teams is to make an entire CAD model, an entire CAD assembly of their vehicles, and driver forms a very important component of that vehicle. um, not just from the point of just from aesthetic point of view, but also there are certain regulations which require you to make a CAD model with the driver in your car. So normally what teams do is they start looking for online CAD models, pre-made CAD models of drivers, and as they do it for the engines, for gearbox, for wheels, for rims as well. But it's very simple to make a CAD model of the driver yourself, and you just have to worry about the various motions that you have to equip your the CAD driver assembly with, and then you can make your driver sit or stand or lie in any position, any driving position that you want. So normally, see, if you look at this particular driving position, so if you just ignore the hands at the moment, then this is a completely lying down driving position, which is more suitable for a formula style race car. So if you can just bend the legs a little and straighten up the back a little, then you can make the seating position of a Baja car or of a rally car. Okay, so what you have to worry about the most over here is the various joints that are there, that are present in a normal human body, that you have to also equip your driver with, so that you can alter these joints and you can change the configuration of the human body and make your driver sit in any position that you want. So if you look at, we'll start from the bottom, and from the bottom, the first joint, if you don't worry about the angles over here, because these only get actuated when you are pressing the pedals, and they normally don't get actuated a lot when you're sitting still, and that's what your driver has to do in the car actually. So the first joint that we'll come across is the knee. Okay, so the knee portion is a very important joint. It's the most critical joint, the most significant one, which decides the seating position of the vehicle. After that comes the hips. So now your torso and your thighs get bent from the hips. So this the angle that is created between the torso and the thigh is decided by how much movement is there at the hips. Then comes the shoulder. Okay, then comes the elbow, and after that the neck region. Okay, so over here what we'll try to learn is by using very basic tools, very basic shapes, how can we make a human body which can simulate a driver in the best way. Now you don't have to worry about the complexities of a real human body. You just have to make sure that you have the right dimensions for the human figure for which you are designing the car. So the first step I would suggest will be to take the measurements of a suitable driver for your car. So if you are having a particular driver which is there in your mind while you're designing your car, then take all the measurements of that driver, and that measurement includes the length of the lower part of the leg, the length of the thigh, and the length of the torso, the length of the biceps, the length of the forearm, so on and so forth. So whatever parts that you're seeing over here in this driver, you have to take all those measurements. Now the very fundamental part of any human body is the torso. Okay, and you can visualize the torso as a kind of a kind of a hub from which all the parts are connected. So if you see, this is the torso and the neck is connected, and both the shoulders are connected over here, then you have the hip joint over here. So this is the most fundamental part of the human body. So what we'll do is we'll try to open this part separately and we'll have a look at how this part appears to be. Now you can see it's a very simple geometry. I have not tried to complicate it by including a lot of curves or a lot of complicated shapes, because I don't need them. I just need to something that can look like a human torso. And this is not a rectangle, it's a kind of a trapezium which is narrowed down a little so that it can form a waist. Shoulders are a little bit broad, and the geometry that I have given over here is you can see some certain hollow spaces over here, some spherical hollow spaces. So I hope you all can understand that the spherical hollow cavities are there to install the various shoulders, the thighs, the hips, and the neck. Okay. Now why I've given spherical, it'll be more clear when I'll try and simulate it in the final assembly. But whenever you visualize any of your joints, then there's always a rotational movement in the joint. Okay, so if you imagine your head, then you can rotate your head in any direction you want. So I think, and you are free to choose your own constraints while making your own assembly, but according to me, a sphere is the most suitable way in which you can simulate that movement. Okay, so that's why I've tried and used sphere everywhere possible, because all the joints almost behave in the same way, except a few where you have certain more constraints, one or more extra constraints. Otherwise they are almost the same. So here we have the torso, we have two sockets for the shoulder, we have a socket for the neck, and we have two sockets for the hips. Okay, now let's go back to the assembly. Okay, now we'll start from the bottom. Let's go to the ankle first, the knee first. Okay, now you can see there is a particular angle between the lower foot and the thigh. Okay, now let's see how the thigh looks. Let's open the thigh in a different in a separate part, and we can see that the hip of the thigh is bulging out, because it has to go into the hollow cavity on the torso. But the lower part of the thigh forms a hollow cavity. So this hollow cavity is actually you can actually relate it to your the cup and socket geometry of your knee. Okay, so this is the socket in which your knee has to go. Okay, so if we again go back into the assembly, we'll see that the knee is actually fitted into the socket, and it is free to move. Now let's see, if I try to move it, then the selected component is fully defined. So I have actually defined the entire component so it cannot move. So my driver is sitting in a predefined position which I have decided for any particular car that I am working on. So if I go into this part, lower foot, I see that there are 4 kinds of mates that I have given. The most basic mate that I have given over here is concentric. The bulging part of the lower foot, which you can call your knee, and the hollow cavity in the thigh are concentric to each other. Alright, so I have constrained them so that they can move relative to one another, and I can simulate the motion of the knee. Then what I have given over here is one of the orthogonal planes of the thigh and one of the orthogonal planes of the lower foot. Now which ones are these? I cannot name them distinctly, but you can get a feel of what I'm trying to do over here. These planes are parallel to each other. Now my leg, if you look at this ankle over here, then I cannot rotate the ankle in this or in this direction. You cannot do it in your foot. Of course, there are certain flex that you can do, but if I'm making a suppose if I'm making a driver, then I don't require my driver to do rotatory motions with the ankles. So the only motion that I'm looking for is this angle that is over here. So I can just move my leg up and down, with respect to the thigh. So that's the only movement that I'm looking for. So I have to constrain all the other movements. Okay. So this parallel movement, this parallel constraint has constrained the rotatory movement of the lower foot. Then I've given a perpendicular. I've given a perpendicular mate. Sorry about that. This perpendicular mate is between the front plane of the torso and the orthogonal plane of the lower foot that was actually constrained with the thigh as well. Okay, so this also forms a relevance when you look at the complete movement this part can go and the actual movement that a human body goes through. Okay, now the final mate that I have given is the angle between the thigh and the lower foot. Okay, now this decides the seating position. This decides the extent up to which your legs can go forward in towards the front end of the car, or they have to come backwards away from the front end of the car. So if suppose I suppress this mate for a little while, then what I can do is I can lift my leg up like this. Alright, now suppose if these mates wouldn't have been there, then there would have been a problem. Suppose if I suppress this mate, then I can do like this as well, but I don't need this movement. Alright, so what I'll do is I'll again unsuppress it. Right, so again I come back to the normal position. Right, now the angle the only movement that I need in this part of the leg is to go like this. Alright, so when I am done with all these four mates, then I'm actually I've done whatever I have to do with this entire part of the leg. So my this lower part of the body is complete. Now what I have to worry about is how my thigh is connected to the torso. So if I look at the thigh, suppose, and if I look at the mates that I have given, then one mate is the concentric mate. That, of course, I hope all of you can relate. This concentric mate is between the hollow cavity of the torso and the spherical convex part of the thigh. So they are concentric to one another, so they'll move relative to one another like a ball and socket joint. And then there is another concentric mate, which is the concentric mate between the knee and the thigh, the lower part of the leg and thigh, which is not relevant in this case. Then parallel also in the same, the lower foot and the thigh, not relevant. Perpendicular, yes. Now the torso has to be perpendicular to the thigh. Now it's not worth discussing this over here. Let's move on to the next mate, and then we'll come back to the earlier one. Okay, now you can see that this is the angle that we are talking about over here, the angle between the thigh and the torso. Okay, so this decides the seating position, how much upright your driver has to be. So if suppose I suppress this mate, then I can take the leg of the driver up and down like this. Alright, excuse me. Okay, so that's the functionality of this part, and again I'll have to unsuppress it. So again my driver reaches to the normal position that I have decided for it. Then the next angle is this angle, which is again irrelevant for this particular joint. Okay, if suppose what I do is, if I remove this perpendicular, if suppose I suppress the perpendicular mate, the thigh can go again like this, which I don't want this movement to be there. Okay, though your thigh may move a little bit like this in a normal human body, but I don't want it to be there with the driver because I don't need this movement. So I'll again unsuppress it. Okay, so far the lower part of the human body is covered. Now we have to worry about the shoulders. So let's look at the biceps. Okay, so mates that we have given over here is concentric again. Now let's biceps is a little different from the other parts. Excuse me. So if I open the biceps, then you can see that this is, it's very significant, very distinctly visible. You can see the shoulder part over here. Then you have a spherical concave, a convex bulging out portion over here, which will go into the socket in the torso. Again, the ball socket joint. And then you have your biceps. So you have to, if suppose you are measuring a driver, then you have to measure this entire length. Okay, and then you'll have to make the size biceps according to that. All right, so I have installed this biceps into the torso, and if I look at the part and look at the mates, then again first mate is the concentric one. All right, then parallel, of course my biceps has to be parallel to the, while I'll be driving. Okay, so by biceps, it's for simplicity's sake, of course. Your biceps will not be exactly parallel to your torso, but if suppose I'll not make it parallel, then many times my the both the arms of the driver will not be exactly in the same position, so it will not look good. All right, so just for simplicity's sake, I have given a parallel mate over here. So you may not give it, and you just by the cursor itself you can decide the position of the biceps. And then again there's a concentric over here, which is not much relevant in this case. Now there is no angle mate over here, so that means my biceps can move up and down like this. Okay, it cannot, if suppose I try to move it outside, it cannot move. It is still moving up and down, though it may appear that it's moving outside, but it is not, because a parallel mate is there between the torso and the biceps. So it's moving up and down, right? Okay, similarly if I look at the ankles, it's pretty much same as the knee. The forearm, not the ankles. The elbow. Yeah, so only a concentric mate. So again this is free to move. Okay, so these two parts can move relative to one another. Alright, now the last joint that is there over here is the neck, the head. Alright, the mates, again there is a concentric mate between the bulging portion and the cavity. There is a parallel mate, there's a parallel mate between the central plane of the head and the central plane of the torso. They'll be parallel, of course. And then there's an angular mate. Now this angle mate is also very critical, very crucial when you're deciding a driving position. Okay, so if suppose I suppress this mate, then I can rotate the head of my driver. So for very fine adjustments I can use this thing over here to adjust the head position of the driver. So pretty much you are covering the entire degree of freedom that is available with your body. Okay, and you have created a driver that you can simply place in your car. Okay, and it'll satisfy all the requirements of a driver, of any percentile driver that is needed as per the regulations or as per aesthetic requirements of your CAD model. Okay, a very brief understanding of the tools that we have used over here. If you open the thigh, then this if you're if you understand CAD modeling thoroughly, then you can understand this is a simple loft feature that I have used to create this shape, and then a dome. Alright, and then the revolve cut to cut out this section. Pretty much everything will be created like that. Okay, if I go to the biceps part, then again the bicep is created using the loft, a cut revolve to create a socket, right, a revolve to create this bulge. You can use any feature, okay, if you want. So you can even use dome over here if you want, if you can manage with the help of that. Then an extrude to create a little bit of a head for the shoulder, and then you, again a revolve to make a bulge which will fit into the socket in the torso. Alright, and this we have already discussed how we have made the torso. It's a simple trapezium with all the sockets required for fitting in all the parts, right. So many people waste a lot of time in searching for a particular CAD model or for a particular driver CAD model on the net, on the web, and then they try to fit that CAD model into their vehicles, which sometimes if you're very lucky then it matches, otherwise you'll have to make the entire car according to the driver that you have found. Instead of wasting your time on the net searching for the particular CAD model, you can very simply make your own, and maybe it's not that professional as the CAD model that you find designed by professionals on the net, but still it'll be your own and you have something to flaunt about as well. So I hope this helps you a little bit in simplifying things, and in especially the CAD modeling part of your vehicle development. And if you have any problems, any things that you want to clarify in this particular tutorial, then please let us know, post your comments, and you can also reach us through email, and do let us know your views on it. And please also do let us know if you have any specific queries on which you would like us to make certain videos. And hope you all enjoyed this video. Thank you very much for watching it. All the best.